So we have this class opener that pretty much reviews the skills that we need for section 7.5, which is actually graphing exponential growth functions. Let's focus in on the first couple of these where it says graph the following. And when we say graph, you might be expecting to see y equals mx plus b. That's from semester 1, and I hope you guys remember that your m is a fraction rise over run. Your b value tells you where it crosses your y-axis, right? It's your y-intercept value. So right here you don't have y equals mx plus b. If you wanted to, you could rewrite it as y equals 0x plus 2. But that in reality is kind of a waste of time. But just to show you guys that you could look at it in y equals mx plus b form, it does cross the y-axis at 2. So let's put a dot right at 2 on the y-axis. Now remember, this is the x-axis, that's why it says x right here. This is the y-axis, that's why it says y right here. Anyhow, we know that the line passes through the y-axis right at this point. It's actually the coordinate 0, 2. Okay. From this point, you need to rise and run according to your slope. But if you look at the slope, there is no slope. Right? That's what I put right here. There is no slope, which means that it's totally flat. You're not going up or over. It's just totally flat. So when there is no slope, it's kind of like me telling you, how steep is the floor? Well, the floor is not steep at all. It's the opposite of steep. It has no slope. And that's exactly what this is, no slope. So let me draw my line right through that coordinate with absolutely no slope. And there it is. I graphed it. That blue line is the graph y equals 2. Now, there was a shortcut that I showed you guys back last semester. If you have x equals a number, you draw a vertical line right through that value of x. If it says y equals a number, you draw a horizontal line right through that value of y. So right here, let's use that shortcut. Does it say x equal or y equal? It says y equal, so we're going to go to the y-axis. We're going to put a dot at -4, and we're going to draw a horizontal line right through it. And that's it. Done. Once again, whenever you have y equals a number, like right here, or obviously both of these have y equals a number. Whenever you have y equals a number, it's going to be a horizontal line. It's going to be a flat line, left to right. And when you have x equals a number, it's going to be a vertical line, up and down. So for example, let's just say that I had x equals 3. Well, that'd be the x-axis, which is this one. You go to the value of 3, you put a dot there, and it's going to be a vertical line going right through there. Just to show you, or just to remind you of how to graph x equals 3. Now y equals, it's a horizontal line going through the y-axis at that value. Now I'll tell you, on section 7.5, we are only going to be applying the y equals a certain number. It's going to be horizontal lines that we're looking at. We'll get to that in the future. I just hope you guys understand how to graph y equals 2 and y equals -4, or y equals any number for that matter. If I tell you graph, let's say y equals 3, well, then you just go to 3, put a dot there, and draw a line right through it. If I tell you graph y equals -1 down here, okay, we'll go to -1 on the y, put a dot there, draw a line right through it. See, it's easy. Let's move on. So you're going to need to know that skill of graphing y equals a certain value, which is a flat line, horizontal line. And of course, we also need to know the definition. What does y-intercept mean? It means where it crosses the y-axis. So it says, what is the y-intercept of number 2 above? Well, first of all, let's define it. What does y-intercept mean? It means where the line crosses the y-axis. Okay, and what is the y-intercept of number 2 above? Okay, let's look at number 2. And number 2, it's y equals -4, so you went to -4, draw a line right through it. So where does it cross the y-axis? It actually crosses right here at that location, and that location is actually the coordinate 0, -4. Okay, simply the b value. That's your y-intercept. Or you could actually write in words, y-intercept is -4. But most of the time we want to write it specifically as a coordinate. Let's move on. Down here. It says find the x and y-intercepts of the following functions. Remember, to find the x-intercept, we set y equal to 0 and solve. To find the y-intercept, we set x equal to 0 and solve. So again, this is also from last semester. Remember the work I asked you to show? It would look something like this, the setup. X-intercept and the x-intercept. On this side, set y equal to 0. That's what you need to know. That's what you need to do. Y-intercept, set x equal to 0. That's what you need to do. So you just simply rewrite the equation. It's going to be 2x minus 3y, but instead of y, I want to put a times 0 right there, equals 6. So you have the equation 2x equals 6. You divide by 2 on both sides to get x by itself, and you get the answer x equals 3. That is your x-intercept. Now, if you want it as an actual coordinate, as an x and y value, well, you just found the x value being 3. And what was your y value? Remember, you started this problem by setting y equal to 0. So the y value would be 0. Okay, so this is your actual coordinate for the x-intercept value of the equation number 4. And let's look at the y-intercept value. Same thing. You want to set x equal to 0. So rewrite your equation, 2x, but instead of x, we're going to put 2 times 0 minus 3y equals 6. And 2 times 0, that's 0, cancels out. So you really have the equation negative 3y equals 6. And if you want to solve that equation, you're going to divide both sides by negative 3, and you will get y equaling negative 2. This is your y-intercept. Now, of course, if you want this as a coordinate, which is an x and y value, we just said that our y-intercept value is negative 2. So that's our y value of our coordinate of the y-intercept. What is our x value? It's simply 0. We started with setting x equal to 0, so our x value is 0. Let's move on to the next one. By the way, if you remember from last semester, this is in standard form. It's really nice to set up, or to have it in standard form when you're finding the x and the y-intercepts. And the last one, number 5, that's in slope-intercept form. So it's ready to graph. I could put this line crossing the y-axis at negative 4. That's my b value. And from that point, I would go up 2 over 1 because the slope is rise over run, 2 over 1. But we're not graphing. We're finding the x and y-intercepts. So to find the x-intercept, you set y equal to 0. So I'm actually going to write it out. Instead of y equals 2x minus 4, I'm going to say 0 equals 2x minus 4. I set y equal to 0. Remember, the y was up here, y equals, I put 0 equals because I'm setting y equal to 0. Now I'm going to solve. I need to get x by itself. I need to get rid of the minus 4 and then the 2. Let's get rid of that minus 4 by doing the opposite of minus 4, plus 4. Minus 4 plus 4 is 0, it disappears. What you do to one side, you must do to the other. So you're going to have 4 equals 2x. Remember, this is 2 times x, so to get rid of the 2 times, you're going to divide by 2. And what you do to one side, you do to the other side. So 4 divided by 2 is 2 equals x. So x equals 2 is your x-intercept. As a coordinate, that would be an x and y value. We just said the x equals 2. The y value, we already knew we started by saying y equals 0. So let's put a 0 where the y is at. So that's your x-intercept coordinate. Let's do the same for the other one, but instead of setting y equal to 0, we're going to set x equal to 0. Again, to find the y-intercept, you set x equal to 0 and solve. So x is going to become 0. We're going to have y equals 2 times x, 2 times 0, minus 4. So I just replaced the x you see here with the 0. And now let's solve. Well, it's really easy. 2 times 0 is 0. So you really have y equals negative 4, and you don't have to solve anything. It's solved for you. That's your answer. That's your y-intercept value. It crosses the y-axis at negative 4. If I were to draw this line on an xy plane, if I were to graph it, it would cross the y-axis at negative 4. Now if I wanted the exact location, I mean it's already an exact location, but if I wanted the coordinate, which is an x and y value, remember the x value we started by setting x equal to 0, and the y value we just said is -4. So that's your coordinate for your y-intercept value. Let's do one more final exercise here to be best prepared for the next section, graphing exponential growth functions. So let's actually put a number 6 on this class opener. So here is number 6, which is actually a continuation of number 5. I took the same equation, y equals 2x minus 4, and I want you to find the range of y equals 2x minus 4 that corresponds to the domain 0, 1, and 2. Okay, so in order for you to be able to answer this, you need to remember the definition of range. Those are simply the y values of this line, but that corresponds to the domain. The domain are your x values. So you need to automatically think that this function, y equals 2x minus 4, you're going to use that function to make an input-output table, an xy table. And remember, the domain values are the input values. So we're going to take the domain values 0, 1, and 2, and the input values mean we're going to put them into the x position. So you're going to have 0, 1, and 2. And you need to find the corresponding range values, the outputs. So if I were to take 0 and plug it in right there, it would say y equals 2 times 0 minus 4. And of course, 2 times 0 is simply 0, and 0 minus 4 is -4. So your output value is -4. Now let's do the next one. Let's take the value, the x value of 1, and plug it in right there, and it would say y equals 2 times 1 minus 4. And we need to find the output. Let's do the math. Let's get the answer. That'll be the output. That'll be the y value. That'll be the range value, or the corresponding range value for the domain value of 1. So again, 2 times 1, that's simply 2. So we really have 2, and then we have the -4 after that. And we know that 2 minus 4 is -2. So we get -2 as our output for the input 1. Let's go for the last one. That would be plugging in the value of 2 into the x position, plugging in 2 right into the x position, and figuring out what the y value is going to be. And of course, if we plug in the 2 right there, it's going to read y equals 2 times the input 2 minus 4. Let's do the math. And of course, 2 minus 2, or 2 times 2 is 4. So you really have 4, and then you have a -4 right after it. And we know that 4 minus 4 is 0. So for the input 2, we got the output 0. So remember, these are domain, these are range values. So to answer this question correctly, find the range of this equation, of this function that corresponds to the domain 0, 1, and 2. The range, and you could write it like this, r, and you would say the y values, the -4, the -4, the -2, and the 0. So that would be your range. That would be the answer to this question. So all of these are essential skills to really being able to succeed in section 7.5, exponential growth functions.